Hey guys, Sukanya here. Today we're going to be taking a look at this integral, integration 0 to pi over 2 of sine 2x over sine to the power 4x plus cos to the power 4x dx. And in this problem, we are going to be using u substitution as well as a few trigonometric identities. So first off, I want to convert everything into one trigonometric identity so that it's kind of easier to solve the integral. So I know that there's a sine here and a sine here. Let's convert this cos to the power 4x into sine. I know that this can be rewritten as cos squared x and then whole squared. I know cos squared x is equal to 1 minus sine squared x, so I'm going to apply that trigonometric identity here. Now over here we can actually start applying u substitution, and you might be wondering, what are we going to set u equal to? Well, we're going to set u equal to sine squared x, and that is because if you take derivative of both sides, so we get du is equal to 2 sine x cos x, once again just applying chain rule, and then dx over here, 2 sine x cos x can also be rewritten as sine 2x. And what do you know, this is sine 2x dx, this is also a sine 2x dx, so lucky for us we can just replace this whole entire integral in terms of u. So everything is in terms of u. U is equal to sine squared x. This is going to be u, and this is going to be u squared because we have sine to the power 4x. Now for the bounds, these were the bounds when the integral was in terms of x, but now the integral is in terms of u. So we need to change up these bounds in terms of u. So when x is equal to 0, I'm taking this bound over here, the lower bound. U is going to be equal to, and I'm going to use this right over here, u is going to be equal to sine squared of 0, which is just 0. And I'm going to take the upper bound when x is equal to pi over 2. U is equal to sine squared of pi over 2, which is just 1. So our new bounds are going to be 0 and 1. And now I'm going to start simplifying the denominator. And now from here, we're actually going to use this very useful formula. And if you don't know this formula, I have made a whole separate video of problems pertaining to this formula, so go check that out afterwards. But for right now, we're going to use this formula. I see that we have an x and that we have an a. X is a variable, a is the constant, but there is no coefficient in front of x, but there is a coefficient in front of u. So we're going to take that coefficient out. We're going to take this 2 out. So now this 2 is out. I'm going to complete the square in the denominator. And after completing the square, I get this, and this is pretty close to this integral. In that case, x is going to be u minus 1/2, and a is going to be 1/2. Now I'm just going to replace those values of x and a on the right side. And now I can just substitute in the bounds, and you should be left with pi over 2, and that is going to be our final answer.